Hello everybody, Innovating Nobel, Namaskar. Welcome to our YouTube channel Nobel Environment Academy. Myself Majid Patel, your science teacher. First of all, I would like to welcome back in our online classes. I hope you will stay with me still end of my class. Now today we are going to read our new chapter which name is as Measurement. Now we are going to read our new lesson which name is as Measurement. Now, concept of measurement. We measure various quantities like length, mass, area, time, temperature, speed, etc. in our day-to-day life. We measure things while buying and selling goods. We measure various quantities to do experiments in a science laboratory. To measure a physical quantity, we compare that physical quantity with a known standard quantity of the same kind. Quantities are length, mass, area, time, temperature, speed, etc. are the physical quantities, and the standard quantities means the actual quantities. Like this scale is a standard quantity and this pencil is a physical quantities. When we measure, we use the standard quantities on the physical quantities to get the measurement. So, measurement is the comparison of an unknown physical quantity with a known standard quantity of the same kind. Example we can see here, this beam balance here is a standard quantity which weight is actual, and here is the physical quantities which weight is not actual. So here to find the actual measurement or to measure it, we have to put these physical quantities into the beam balance. Or another example is to measure the length of the pencil, we have to use standard quantities which is this scale. When we put the standard quantities on the unknown quantities, we can measure its length. So its length is 15 centimeter. Different tools or instruments are used to measure different physical quantities. For example, a beam balance is used to measure the mass of a body. A spin balance is used to measure the weight of a body, and a watch is measured time, and a meter rod or scale is used to measure the length of a body. Now we have finished the concept of measurement. Now we are going to read what are the importance of measurement. Now we are going to read about the importance of measurement. The importance of measurement in our daily life is given below. They are: number one, measurement makes buying and selling goods easier. In our daily life, we always measure in the shop while we buy some sugars or anything else on the shop. The things should be measured while buying. It helps to get the accurate amount of physical quantities. When we go to the shop and we get the accurate amount of sugar, soap or another things, it is important to perform experiment in a science laboratory, and measurement is also important to perform any experiment in a science laboratory. And measurement is important in the laboratories for getting proper amount of medicine. In also medicine, the measurement plays a vital role. For example, if we feel sick, the doctor said us to eat half tablet, or as your age, the doctor prefers to eat you the medicine. It is important in construction of road, buildings, bridges, etc. These are the importance of the measurements. Now we are going to another point, which is known as physical quantities. What are physical quantities and what do you mean by physical quantities are given below. The quantities like length, mass, time, area, volume, temperature, etc. can be measured. These things are measured. These quantities are known as physical quantities. So, those quantities which can be measured are known as physical quantities. Once more, those quantities which can be measured are called physical quantities. And what are the physical quantities? Their examples are, some of their examples of the physical quantities are force, speed, pressure, acceleration, energy, power, electric current, etc. We cannot measure love, feeling, kindness, anger, beauty, desire, happiness, etc. So they are not called physical quantities. There are two types of physical quantities. They are fundamental physical quantities, which examples are length, mass, time, temperature, etc. Once again, there are two types of physical quantities. Among them, number one is fundamental physical quantities, which examples are length, mass, time, temperature, etc. The second one is derived physical quantities, which examples are area, volume, speed, etc. Now, unit of measurement. We all know about the measurement. Measurement is known as the comparison of an unknown physical quantities with a known standard quantity of the same kind is known as measurement. And what do you mean by unit? A unit is a standard quantity which is used to compare an unknown physical quantity. A unit is a standard quantity. Previous I have told you that standard quantity means the actual value. A unit is a actual value or standard quantity which is used to compare an unknown physical quantities. Previous topic was the physical quantities. I have told you that physical quantities are those quantities which can be measured, are known as. Similarly, physical quantities are measured in terms of unit. Once again, a unit is a standard quantity which is used to compare an unknown physical quantities. Similarly, physical quantities are measured in terms of unit, that is meter, which symbol is small m, second, which symbol is small s, Newton, which symbol is capital N, Pascal, which symbol is capital P and small a, etc. are some example of unit. And unit are of two types, that is fundamental unit and derived unit. The unit of fundamental physical quantities. The unit of fundamental physical quantities like meter, kilogram, second, etc. are called fundamental or basic quantity, basic unit. Once more, the unit of fundamental physical quantity like meter, kilogram, second, etc. are called fundamental or basic unit. These units are independent of each other. These units are independent of each other. So the unit which are independent of each other are called fundamental or basic unit. Similarly, the derived unit. The derived units like area, volume, speeds are called derived unit. Here we have read about the physical units, and now I am going to tell you about the derived unit. Please listen carefully, because in your book there isn't written the derived unit. So the units of derived physical quantities like area, volume, speed, etc. are called derived unit. These units are dependent on fundamental units. So the units which are dependent on fundamental units is known as derived unit. Now see on your now look on your book. There are 7 fundamental units in the SI system which are given below. Here in this box, these all are the fundamental units, and in the second box these are the symbols of these fundamental units, and these are the physical quantities. Number 1, the fundamental units are meter, which symbol is m, and it is measured in with length. And the second is kilogram, which symbol is kg, and this physical quantities is mass. And third one is second, which symbol is as small s, and which physical quantities is time. It is measured in time. And number 4 is Kelvin, which symbol is capital K, and it is measured in temperature. Number 5 is ampere, which symbol is A, and it is measured by electric current. Number 6 is candela, which symbol is CD, small c and small d, which is measured by luminous intensity. And number 7 is mole, and which symbol is MOL, and it is measured by amount of substances. In Nepal, departments of weight and measure in Kathmandu maintains the standard unit to measure different physical quantities. In Nepal, there is a department of weight and measure, where in Kathmandu it maintains the standard unit to measure different physical quantities. The department of weight and measure of Kathmandu maintains the standard unit to measure different physical quantities. The standard kilograms for measuring mass and the standard meter rod for measuring length are kept at Department of Weight and Measure in Balaju. The standard kilogram and the standard meter rod are the copies of the prototype of the standard kilogram and standard meter rod of the International Bureau of Weight and Measure in Paris branch. The kilogram or this is the standard meter rod which are kept on the International Bureau of Weight and Measure in France, and this is the standard kilogram which are kept in France. And in Nepal of the Balaju, there is also actual meter rod and the kilogram, which is also known as the standard meter rod, and standard kilograms was kept on the Department of weight and measure in Balaju. Now we are going to read about the local system of measurement. Local means where we are living. In rural areas, people use mana, pati, dharni, muri, pau, sir, chatak, etc. to measure the different mass of different goods. Similarly, they use hath, cubit, bitta to bitta, out state palm. Here is the photo figure, foot, etc. to measure the length of different object. These units vary from person to person and hence give different measurement of the same object. Do you know why this measurement vary from person to person? Because the bitta or outstretched palm are not same of all person. So if you measure anything with your palm, that will be vary from other person. For example, your book. For example, with my hand, with my pitta or outstretched palm, your book is only one outstretched palm. Therefore, these units of measurements are not reliable due to lack of uniformity as they differ from place to place and person to person. In bringing uniformity in the units of measurement throughout the world, scientists have developed different systems of measurement and standard quantity. In the local measurements, if anybody will measure, it will be vary from one person to another person because their measuring instruments may be short or long. So that the scientists have developed many systems of measurement with a standard unit. This system of measurement helps to maintain your uniformity in measurement throughout the world. Now we are going in the topic of system of measurement. In scientific measurement, three systems of measurement are commonly used, which are as follows. There are only three systems are follows. They are as follows. Number one, MKS system. This capital M, capital K and capital S system. Number two is CGS system and number three is FPS system. Now in number one, MKS system. MKS system is the system of measurement in which the length is measured in meter. Listen carefully here. And mass is measured in kilogram and time is measured in second. Once more I am going to say, MKS system is a system which is measured, length is measured in meter. The capital M denotes the meter, so length is measured in meter and K denotes the kilogram, so mass is measured in kilogram and yes, this capital S denotes the second, so time is measured in second. This system is commonly known as metric system. This MKS system is commonly known as metric system. The extended form of MKS system is called SI system. This MKS system is known as SI system. SI system is the extended form of MKS system. It is accepted and followed throughout the world. This MKS system followed throughout the world. Now, number 2, CGS system. Remember the capital letters? CGS system is the system of measurement in which the length is measured in centimeter. In MKS system, the length is measured in meter, mass is measured in kilogram, and time is measured in second. But in CGS system, the system of measurement in which the length is measured in centimeter, mass is measured in gram, and time is measured in second. It is a French system of measurement. We should be clear in the MKS system, CGS system and FPS system. I am going to repeat once again. MKS system is the system of measurement in which length is measured in meter. We have to note this point. Length is measured in meter, mass is measured in kilogram, and time is measured in second. But in CGS system, length is measured in centimeter, mass is measured in gram, and time is measured in second. And CGS system is a French system of measurement. Now, number 3, FPS system. FPS system is the system of measurement in which length is measured in foot. Length is measured in foot, mass is measured in pound, and time is measured in second. So, it is a British system of measurement. Now, we are going to read about length and its measurement. Length and its measurement. What do you mean by length? Length means the distance between any two points is known as length. For example, the corner of your book, one corner to the another corner of your book, the distance between the one corner and the another corner of the book is known as your book length. So, the definition is the distance between any two points is called length. For example, the length of a stick is 2 meters, means the distance between the upper tip and the lower tip of the stick is 2 times of the meter rod. The length of the stick is 2 meters, means the distance between the upper tip and the lower tip of the stick is 2 times of the meter rod. In our practical life, we use different form of length like breadth, thickness, depth, radius, height, diameter, etc. We use different measuring device. Such as scale, inch tape, meter rod, measuring tape, etc. to measure length. Now, length is a fundamental physical quantities measured in meter. Unit is SI system. In SI system, length is measured in meter. To measure the length, the given object is compared with the standard length of the scale meter or measuring tape. So, length is also measured in millimeter, centimeter and kilometer. These are the multiples and sub-multiples of meter. Now see here, 1000 meter is equal to 1 kilometer and 1 centimeter is equal to 10 millimeter and 1 centimeter is equal to 100. 1 centimeter is equal to 100 centimeter, and 1000 millimeter is equal to 1 meter. We measure shorter distance in meter. Sometimes meter is considered too shorter to measure very long distance such as length of river. Sometimes meter is considered too short to measure very long distance such as length of a river, highway, etc. Such distance are measured in kilogram, mile, etc. This very long distance are measured in kilometer, miles, etc. Similarly, very short distance are measured in millimeter and centimeter. The longest meter are measured in kilometers and miles. The shortest distance are measured in. Now, mass and its measurement. The total quantity of matter contained in a body is called mass of the body. The total quantity of matter contained in a body is called mass of a body. The mass of the body depends on the number of atoms and the mass of each atoms of that body. The SI unit of mass is small m is kilogram. The SI unit of mass is kilogram. Mass is also measured in gram, milligram, etc. The mass of a body does not change from place to place, so it is called a constant quantity. We must know the mass of a body does not change from place to place, so it is called a constant quantity. The mass of a body is measured by a beam balance or physical balance. This is known as beam balance. The object whose mass is to be measured is placed in the left hand pan, and the weight or standard mass are added to the right hand pan until the beam attains equilibrium. Here is the example. This is the standard quantities, standard unit, which weight is actually fixed. In this beam balance, on the left hand side, the weight or the mass is kept, and on the right side the standard unit is kept until the beam balance attains equilibrium. Equilibrium is perpendicular. In the position, the total mass of weight on the right hand pan gives the mass of the object. The mass of the light object is measured in. Light means having small weight. Objects is measured in milligrams, grams and kilograms. Similarly, the mass of heavy object is measured in quintal, metric ton, etc. The submultiples and multiples of the kilogram are as follows. Here are the submultiples and multiples. 1 milligram is equal to 1 upon ones, tens, 100, 1000, 10,000, lakh, 10 lakh. 1 upon 10 lakh kilogram is equal to 1 milligram, and 1 gram is equal to 1 upon 1000 kilogram. And the multiples are 1 quintal is equal to 100 kilogram, and 1 ton is equal to 1000 kilogram. Now we have read about the length, mass, and now we are going to read about the time and its measurement. Time is defined as the duration between any two events. The SI unit of time is second. It is determined on the basis of time taken by the earth to the rotation in its own axis. The time is determined by the rotation of the earth. The time is determined on the basis of the rotation of the earth in its own axis. A watch or clock is used to measure time. A watch or a clock is used to measure the time. One mean solar day is defined as the time taken by the earth to complete one rotation around the sun about its axis. One means solar day. One means solar day is defined as the time taken by the earth. The time taken by the earth to complete one rotation around the sun about its axis is known as one solar day. The time duration is divided into 24 intervals. One intervals out of 24 intervals of a mean solar day is called 1 hour. One intervals out of 24 intervals of a mean solar day is called 1 hour. The duration of 1 hour is divided into 60 equal intervals, one intervals of which is called 1 unit. Its numerical is given here. 1 minute time is divided into 60 equal intervals, one intervals of which is called 1 second. Here 1 intervals out of 24 intervals of a mean solar day is called 1 day. 1 day is called to 1 intervals out of 24 intervals of a mean solar day is known as 1 day. And for hour, 1 intervals out of 24 intervals of a mean solar day is called 1 hour. And for the minute, the duration of 1 hour, divides into 60 equal into 60 equal intervals, into 60 equal intervals, one intervals of which is called 1 minute. This is one is in minute. Conservation of 1 day into second. 1 day is equal to 1 multiplies 24 hours. 1 day, in 1 day there is a 24th hour, and in every hour there is a 60 minute. So it is multiplied by 60, and in every 60 minute there is 60 seconds. So we have multiplied here with a 60 seconds. So by multiplying 1 multiplies 24 multiplies 60 multiplies 60 seconds is equal to 86,400 seconds. So 1 day is equal to 86,400 seconds. Here is some note. 1 second time is defined as 1 part of 86,400 part of a solar day. Now, a variety of clocks like mechanical clock, which is also known as pendulum clock. This is known as the pendulum clock. Quarters clock and atomic clock are used to measure time. This quarters clock, mechanical clock, which is also known as the pendulum clock, and atomic clock are used to measure time. A mechanical clock or pendulum clocks works on the basis of the oscillation of a simple pendulum. Oscillation means goings of one time on the right side or on the left side. This type of clocks cannot measure time accurately. These types of mechanical watch or pendulum clock do not measure the time accurately. Quarters clock work due to the vibration of quarter crystal. This quarter clock measure the time works by the vibration of the quartz crystal. It is more accurate than mechanical clock. This quartz clock is more accurate than the mechanical clock. Similarly, an atomic clock works due to the emission of radiation by CS-133 isotopes. It measures time most accurately. There is an atomic clock which works with the emission of radiation CS-133 isotopes, so it measures more accurately. Now I am going to give you the homework. Number 1, what is measurement? Number 2, write down the importance of measurement. Number 3, define physical quantities with any 3 examples. Number 4, give any 3 examples of local system of measurement. 5. Define unit. Write down local units and standard unit of mass. Number 6. Define MKS system of measurement. Number 7. Define CGS, CGS and FPS system of measurement. Number 8. What is length? Question mark. Write down standard unit of length. Number 9. Define mass and write its standard unit. Number 10. What is time? Name the device which is used for measuring time. If you are new in my channel, please subscribe our channel and touch the bell icon to get the new videos, and please like, share and comment us.